Imagine a world without clocks, decay, or progression. A reality where heartbeats echo infinitely, thoughts linger forever, yet nothing truly begins or ends. This terrifying stillness might be our true, deeper state. From the ethereal glow of distant nebulae to the silent majesty of orbiting black holes, the universe beckons. Our insatiable curiosity about the cosmos has driven humanity to remarkable feats, launching telescopes to peer into the past, sending probes to touch other worlds, and devising theories to unravel the very fabric of existence. Space research isn't just about discovering new planets or distant galaxies. It's a relentless quest to understand the fundamental laws that govern everything, including the most elusive and profound dimension of all, time. We perceive time as an arrow, ever moving forward, a constant and unyielding progression from past to future. It's embedded in our biology, our physics, our very sense of being. Einstein revolutionized our understanding, revealing time as not an absolute, but a dynamic component of spacetime, capable of dilation and contraction, depending on gravity and velocity. Yet, even in the most extreme cosmic scenarios, time always flows. But what if it didn't? What if one incomprehensible instant, time itself simply stopped? Not just for us, but for every atom, every photon, every galaxy in the entire universe? This isn't a mere philosophical musing. It's a scientific thought experiment of staggering proportions, designed to probe the very limits of our understanding of reality, causality, and existence itself. To truly grasp the implications, we must first confront the nature of time as revealed by our most advanced space research, and then dare to imagine a cosmos where its relentless march ceases entirely. What would such a universe even be? And what could space research, past, present, or future, tell us about it?
Imagine, if you can, the profound implications. If time were to stop, causality, the very bedrock of our physical reality, would instantly unravel. There would be no before and after, no sequence of events. Photons, which normally travel at the speed of light, would cease to propagate. Light itself would be frozen in place, unable to reach our eyes or instruments. The stars would no longer emit light. They wouldn't even be stars, as the nuclear fusion processes that power them rely on continuous temporal progression. Every subatomic particle, every electron orbiting an atom, every proton within a nucleus would halt its motion. Chemical reactions would cease. Biological processes, from the beating of a heart to the firing of a neuron, would instantly terminate. Life, as we know it, is fundamentally a series of processes occurring over time. Without time, there is no process, no change, no life, no thought, no consciousness. The universe would be an eternal, infinitely dense snapshot. Black holes, those cosmic titans defined by their gravitational pull and dynamic event horizons, would become static singularities, their space-time warped but utterly unmoving. The expansion of the universe, a constant motion driven by dark energy, would cease. Galaxies would be fixed jewels in an unyielding cosmic tableau. But here lies the profound paradox. If time stopped completely, there would be no observer, no consciousness to perceive this ultimate cessation. There would be no us to witness the frozen cosmos, no instruments to record it, no memory to recall the moment it happened. The universe would simply be, in an eternal, changeless instant, stripped of all its dynamic glory, a silent, inert monument to what once was.
Given the utter impossibility of perceiving time's cessation from within, our only hope lies in understanding the conditions before such a catastrophic event. This is where advanced space research becomes paramount. Our quest for a unified theory of quantum gravity, one that reconciles Einstein's relativity with quantum mechanics, is essentially a quest to understand the fundamental nature of space-time itself, and by extension, time. Particle accelerators, our terrestrial cosmic colliders, probe the very essence of matter, seeking exotic particles and forces that might offer clues to dimensions beyond our familiar four. In space, observatories like the James Webb Space Telescope push the boundaries of our cosmic vision, allowing us to witness the universe in its infancy, searching for anomalies in the cosmic microwave background or the distribution of dark matter that might hint at underlying temporal mechanics. Could there be subtle precursors, ripples in the spacetime fabric that our future instruments might detect? Perhaps fluctuations in gravitational waves or unusual decays of particles in distant supernovae could signal an impending temporal breakdown. Furthermore, theoretical physics explores concepts like extra dimensions, wormholes, and even cyclical time, suggesting that our linear progression might just be one facet of a much grander, more complex temporal reality. Could advanced civilizations, far beyond our current understanding, possess the knowledge or even the technology to perceive, manipulate, or even restart time? While pure speculation, these thought experiments illuminate the vast unknowns that our continued exploration of space and fundamental physics aims to unveil. The hunt for gravitational waves, for example, is not just about black hole mergers. It's about listening to the universe's most fundamental vibrations, which could carry whispers of time's deeper secrets.
The what if time stops scenario, while a radical departure from our experienced reality, is far more than a fantastical concept. It forces us to confront the very essence of existence. What is reality if change is impossible? What is meaning without progression? Such a universe would be utterly static, without memory, without hope, without purpose. It underscores how deeply intertwined time is with our definition of life, consciousness, and the dynamic, evolving universe we inhabit. Our space research, from mapping dark matter to searching for exoplanets, isn't merely about cataloging cosmic objects. It is, at its core, an endeavor to understand the universe as a complete system, including its fundamental dimensions and forces. The persistent pursuit of a theory of quantum gravity, of understanding the Big Bang with greater clarity, of exploring black hole thermodynamics are all attempts to unravel the ultimate secrets of time itself. Could time be an emergent property of the universe rather than a fundamental one? Could it be woven into a tapestry of dimensions we are only just beginning to conceive? The power of this thought experiment lies not in predicting a looming temporal apocalypse, but in pushing the boundaries of scientific inquiry. It compels us to ask uncomfortable, profound questions about the nature of reality and to continue our relentless scientific exploration, both outward into the cosmos and inward into the very fabric of space-time. For it is only by seeking to understand the most extreme possibilities that we can truly begin to grasp the miraculous, ever-flowing reality we currently inhabit, and perhaps, one day, even comprehend the ultimate origins and destiny of time itself.
Subscribe to the channel and hit the bell icon for more amazing videos.